Hello, how are you guys doing today? Happy Tuesday. Still got a few more exams to grade. I was working on grading some other stuff for 4397, but just got a few more. And then I will post the grades. And I'm also grading, if you guys probably noticed, some of you noticed, grading everything. So I should have grades for the IP address assignment. And if you're missing any grades, before you email me, let me finish tonight. Finish those grades. We're going to finish up the rest of chapter 9 today, which is the wide area network chapter. And then we'll go over what's going to be on exam 2. And I'll talk more about subnetting if you want me to. And what I'll do, for those of you that were asking, we'll do one or two of the questions of the subnetting assignment, the one that you're supposed to turn in, just to make sure you guys are on the right track with that, okay? I think that'll make some of you happy if we do that. So let me get my screen shared here. Let me open up my browser here. It was quite some weather we had yesterday. Most of you, or some of you, were able to attend class at 6 p.m. yesterday, but if you weren't, I posted the link, and it's hopefully you were able to watch the video on YouTube. Are you guys finding the YouTube videos okay? I'm actually now specifically posting the links, if you notice, the direct links for the youtu.be URL to get there, but you can always Google in YouTube or search in YouTube for Prop Jake or Jake Messenger, and they're there. So I appreciate you saying they're great. I've watched them and they're rather boring, but hopefully they give you the content that you need, that you're needing to study and get the assignments done. So first of all, I need to re-download chapter 9. I'm on a different computer today. I came up to U of H because I needed to reboot some servers here. It's getting a little bit more, there's a little bit more stuff going on here, but still it's very much a ghost town here. And we're not, it's on a volunteer basis. So yeah, there's the links. By the way, I think that's kind of interesting that YouTube did this and some other sites did this. You see that .be right there? Let me just talk about that for a minute. Because one thing that we hadn't really talked about much in the class that I usually do talk about when we get to the internet chapter in the third section, we'll talk more about it, but each country has a 2-digit country extension. Now, a lot of those countries choose to allow only companies within those countries that have presences in those countries to use those TLDs, they call them top-level domains. Some countries which are very small, like the island country of Tuvalu. Anybody ever heard of Tuvalu? It's a small island South Pacific island country. They were assigned a top-level domain extension of TV. And they decided, well, let's sell that. Okay, so in order to get a .tv name, you have to pay significantly more. At one point, I don't know if they're still this expensive or not, but at one point they were charging $300 per year, as opposed to the nominal $15 a year that you could get a domain through on GoDaddy for a .com or a .org. .nets have actually gone up a little bit in price. So I think it's kind of nice that YouTube decided, let's get a .be name so they could essentially shorten their name. That's why they did that. And make some shortcuts to it. So it's not youtube.com, it's youtu.be. Who is .be, by the way? Can somebody go look that up, or you want to take a guess and see who is .be? What country is that? You can Google it like this. What country TLD, top level domain, is BE? Belgium. That's right, Belgium. I thought it was Belarus at first. I could not remember what Belarus is there. Brazil is BR. Probably BU is Belarus. Anyway, keep those kind of things in mind, things that you see and you wonder about. Well, why is this youtu.be? You know, be curious about this stuff. Course content. Like I said, let's just finish up chapter 9. And by the way, I have been, if you notice, or maybe you haven't noticed, I've been putting some additional notes in the previous sections that we already had a test on. Like, I found this wiki link, and I thought this was a really good link to describe all the different protocols of the OSI model. Now we're learning the internet model, the network model, the internet model, the 5-layer model. But this still holds true for most of the layers. And I do disagree, and there's a few that are gray areas in terms of whether they're a physical layer protocol or a data link layer protocol. And it somewhat describes that, but this is a very long, very thorough wiki on network protocols. There's also, I also stuck this link in, so make sure you're going back and looking at this, even if we've tested on it, because this is stuff you need to know. Here's a very thorough wiki on the different transmission media types, which will go into even more detail on things that I wasn't able to get to this semester because it was too short. We missed a class, specifically talking about twisted pair copper wiring. Talks a lot about ArcNet, which was the original networking, and I got really nostalgic earlier today, and I was looking up some of these guys I know. ArcNet was the first desktop PC-based networking that was available, and it was invented by one other guy, and this guy, John Murphy, who's still around, and he's a friend of mine. I know him. I know John Murphy. I know Gordon Peterson. He's a good friend. He's the guy that actually invented the mount command, which is what you use in Linux and Mac OS and in Windows, but you don't see it as the mount command, to actually mount a network drive on another computer. He wrote that command. So it's kind of neat. I got nostalgic when I was reading those. But my point is that these links that I stick in there, you need to go look at those because they will be helpful for you in your job searching, or if you plan to take any of the Cisco or the Microsoft Network Certified Engineering certification tests. And by the way, let me just speak to that really quick while I'm downloading chapter 9. I do recommend, I did not used to, mostly because I don't have any of these. Oh, that's the PDF, excuse me. I don't have any. I have a couple of very minor certifications, but none of these Microsoft Certified Network Engineer certifications or Cisco Certified CCNE, CCNA. I don't have any of those, which hasn't really ever caused me a problem because I'm not trying to apply for a job anywhere, but it probably would be a good idea for a lot of you to get those certifications because that's what companies look at on a resume. Some companies won't even consider you to be hired for a network manager or even something that's not necessarily that network oriented, because if you are managing technical people, you do have to have some technical background and they want to see how far you've gotten. So sometimes you can't apply for a job if minimum requirements are Microsoft Certified Network Engineer, Cisco Certified Network Engineer, or there's several of them. So does anybody in here have any certifications, or are you planning to get some certifications, not just with respect to networking, but any certifications in any field you might happen to be in? Like finance, for example, MTA database, okay, that's a good one. There is, you can get certification in SQL, different SQL flavors of certification. MySQL certification, and of course Oracle SQL certification. Once you get those certifications under your belt, you'll find it a lot easier to get a job. You'll look a lot better. Now, should you pay the money to take the courses? In what you guys are learning, a lot of what you guys are learning from my classes, you could probably go take the Cisco Certified Network Engineering course and a test, not course, but the certification test, and pass it. You could certainly take the Microsoft Certified Network Engineer course and pass it, because they teach the network model, the internet model. So pay attention to those links I put up there. Now, this one gets really thorough and talks a lot about fiber optic modes, and maybe it's more technical than you need. So if it gets too technical, skip past that part, past the part that bores you, but scroll all the way through it, because it's very good, mostly correct information. The reason I say mostly correct is occasionally there will be some mentions of who developed what, or mostly historical things, or what they consider a layer 1 or a layer 2. Like, for example, that protocol wiki states that DSL is a layer 1 protocol. That is absolutely incorrect. DSL, which stands for Digital Subscriber Line, DSL, and that still exists. Some of you might have DSL. It is a combination. It's a protocol suite of layer 1 and layer 2. It relies on the layer 1 protocol of twist and pair wiring, the copper wiring that comes to your house, plus a data link layer protocol, asymmetrical, asynchronous transfer mode, or ATM. Its maximum frame sizes, by the way, are only 53 bytes, as opposed to Ethernet being 1,500 bytes. DHCP, they called an application layer protocol. DHCP does work in the application layer, but it has to reach down into the data link layer, all the way down to the data link layer to work. So when I was grading your tests, some of you guys put answers to the protocol questions that were technically not correct, or it was a fuzzy area, but I still gave you credit. Some of where I counted off, by the way, because some of you will notice that I actually modified your grade and I lowered it a little bit in a couple of cases, not too bad, maybe a point. And I tried to make some notes on your exam. The sample addresses, the example addresses a lot of you guys gave were incorrect. IP address was good. Application layer address was good, but transport layer address, a lot of people didn't understand what I was looking for. I was looking for a port number. Physical layer address, I was literally looking for an address, like 1234, or 4801 Calhoun, looking for a physical address. So if you do, after, I have not applied the curve yet, so after I apply the sliding scale on that exam, and you're still not happy with your grade, or you're like on the border between a C and a B or a B and an A, send me an email and we'll discuss it. We'll look at some of the answers on your test, and I might give you a little bit of extra something or other to do to help you out. Okay, so this is about where we had stopped here. I had mentioned that packet switch networking was not really a thing anymore, although this thing, MPLS, is more like Ethernet, although it's considered a packet switch network. When we talk about packet switch networks, we're talking about usually the T carrier service, this T carrier service. They call Ethernet packet switch, but usually we're referring to this old school T carrier service way back here, which we don't really refer to anymore. Fractional T1s or packet switch T1s. Let me go ahead and point out what this is. I did kind of gloss over this really quickly in the last class. A permanent virtual circuit versus a switched virtual circuit. In both of these cases, when you're ordering service, and usually you don't make the decision on whether you get a permanent or a switched virtual circuit, because you may not necessarily know. It's whatever the carrier suggests for you. A permanent virtual circuit is just what it sounds like. It looks to you like a permanent hardwired connection between one of your locations and another one of your locations. It looks like a dedicated network, or it kind of makes your WAN act like a LAN at layer 2. Switched virtual circuits change dynamically. So switched virtual circuits are where you have, as the end user, have a little bit of control over which direction the data is going at layer 2. And you have to have layer 2 switches or layer 2 modems or connecting devices that connect into the carrier that understand how to do switched virtual circuiting. Now, this is much more technical stuff. I don't get into this a whole lot because this is not an information technology class. We're just introducing you as network managers into the terms and the services that are available, so that when a carrier was to throw out a quote at you, hey, we can give you these PVCs or these SVCs, you won't sound stupid when you're talking back to them and go, oh, well, what's a PVC? I don't know what that is. At least you can go Google that. Committed information rate, already mentioned that. So we had just stopped at VPN, so virtual private networks. Now, a lot of you are probably already familiar with, and you use some sort of VPN. I had asked you to attempt to complete a VPN exercise, which you might have been able to do, might not have been able to do. It should have worked. For a lot of you, it did work. For others of you, you were having technical issues, maybe because you were on a Mac or a PC and you had some other software in the way, or you made a typo somewhere. And it's not too difficult if you've done it before, but it is rather foreign when you're trying to use the built-in VPN networking that is built in or comes with the operating systems of Windows and Mac OS. There are several different implementations of VPN. There's probably the most common one is called OpenVPN. And the reason it is most common is because it is open. Now, when I say that term open, that software, this is an application. When an application is open, what does that mean? It means it's essentially free. You can download it for free. You can install it for free. You can modify the source code if you wanted to. And if you make any changes to it, you have to share those changes. Typically, companies that use open systems, which is what my 4397 class is all about, it's a matter of paying later versus paying now. You buy a subscription, for example, for support, for hand-holding. So this OpenVPN software, this application, is actually available in many of the routers that you can buy. Many of the home gateways that you can buy, like Asus, for example, uses OpenVPN. Netgear uses OpenVPN. There is a firmware that you can download called DDWRT, which uses to some degree OpenVPN to do the VPN networking. There's also IPsec VPN. Here, I'm going to type in the basic, I'll type it in the chat window there. IPsec, point-to-point tunneling protocol, and L2TP. And then on top of that, there's different authentication protocols like CHAP and MS CHAP, which stands for Microsoft CHAP. And then Cisco has their own VPN, and Juniper has a VPN. These are the companies that make networking software. So one of the issues, by the way, and I'm getting a little bit ahead, but one of the issues that we do have with VPN when we're trying to implement it is that getting VPN to work between different vendors is sometimes difficult, and that's kind of what you were running into. I tried to use the least common denominator VPN, which was the L2TP VPN, which is a rather old, not as good VPN, and with the authentication method of Radius. And we'll talk about Radius probably next class. So what VPN does, and the reason VPN is so popular, is it provides the equivalent of a private network over the public internet. The way it does that is it creates a virtual circuit that we call a tunnel, and it can be totally software. All you have to have is a connection to the internet, an IP address connection, either IP version 4 or IP version 6, and then VPN software, a VPN application. And there are several that you can download that allow you to appear like you're in another country, like Hola VPN, H-O-L-A. NordVPN. A lot of people use VPNs on software applications to hide where they're coming from. VPNs can be implemented at layer 2, 3, 4, or 5, all the way up to the top. So what a VPN looks like. And there's two general classifications of how VPN is used. You have what's called a site-to-site or a point-to-point VPN, which is what this is an example of. Oops, excuse me, I bumped my mouse. This is a site-to-site VPN, and it's usually called that in most routers that you log into when you're setting up a VPN. It usually uses a special purpose device. This is not software typically that you run on your laptop or your computer. You buy a gateway or firewall or a special purpose device that sits on your network as another node on your network. It's communicating with you. Let's pretend that backbone is really just LAN. Okay, that's a LAN network. Your LAN is communicating with it. It has an IP address, and it is connecting to the internet, and it doesn't matter how it's connecting to the internet. There could be a gateway here in the middle, a router. This guy gets a public IP address, and he is establishing a connection by logging into. You give it an IP address and a username and a password or some sort of authentication key to log into another device running the same protocol. Usually when we set up site-to-site VPNs like this, we use the same hardware on both sides, but not always. Sometimes we mix and match the hardware as long as the protocols that we choose are the same on both sides, that we both decided we're going to use IPsec or L2TP or PPTP, and we're going to use Radius to authenticate, or pre-shared TPSK is what we call that, kind of like using a key for Wi-Fi, your SSID and your PSK, that's that little code that you type in, or maybe even a downloaded key, which is kind of like an SSL key. So like when you go to a secure website, the secure key is found on the internet and downloaded. The advantages to using a site-to-site, using a separate device like this, is that you don't have to run any special software on either one of these two local area networks. What you do is, in this office, let's say this is the home office, your local area network is going to have local IP addresses on it, internal IP addresses, like 192.168.1. everything. The other office, you want to be sure to number it something else, like 192.168.2. everything else. Okay, those are both allowable internal ranges that we can use. This VPN gateway logs into this VPN gateway, and both of these devices have to have either a public IP address, like on this port right here and this port right here, or they have to be talking to a router in the middle that's doing network address translation and translating one single private IP address to a public IP address. So public IPs have to be known because you're passing your traffic over the internet. So what happens is once the tunnel is established, this thing logs into this thing, it essentially bonds these two LANs together so that if somebody wants to send traffic from this network here on the 192.168.2.25, let's say that's their IP, and they want to send something to 192.168.1.50, it'll hit the gateway. The gateway will encrypt and encapsulate that packet, send it through the internet, encrypted to the public IP of this VPN gateway over here. He will decrypt that, take it apart, and throw that packet onto this local area network here. So it essentially connects two or more LANs together, site to site. We call that tunneling because what we're doing is we're essentially taking a lower level protocol, layer 2 or layer 3, bringing it up into a higher level, layer 3 or layer 4 or 5 even, encapsulating it, sending it across the internet, throwing it back out onto the other network, back down, for example, to layer 2. So I have site-to-site connections with many of my clients' offices. My clients have multiple sites. They would rather have a site-to-site VPN like this because this way, if there is a laptop or a PC here or whatever, we don't have to run any special software. That's called site-to-site VPN. Here's some, actually, let me, before I talk about that, this is the opposite of that, or it's a similar, it's not the opposite, it's just another way to do VPN. This is the one that you guys tried to do already, and maybe what you've already done before with your place of business. It's called Road Warrior, though there's different terms for it, but the slang term out in the market is called the Road Warrior VPN. A Road Warrior, that's like a salesperson or a tech guy or a marketing guy that lives in airports or that lives out on the road. I remember when I was going to school here and getting a degree, several of my peers went off and got jobs with the consulting firms, and they spent the first 5 years of their jobs on the road, traveling. I went to, Oklahoma and Beijing and Singapore and Europe, and they were just traveling everywhere using a laptop, VPNing back through whatever prevailing internet connection they could find to get back onto their local network, back onto their local databases somewhere. The way this works is essentially the same way, except the difference is with site-to-site VPN, this is true for most cases, you set up a profile here and you set up a reciprocating profile here, and these two things constantly try to log into each other. If the link is down, this side will try to log into this site. Oh, I'm sorry, I keep hitting the mouse. And this site will try to log into this site. It's reciprocal. It's like two people trying to call each other. Eventually, one of those calls will go through and they'll stop calling each other. So it's a very robust kind of a setup. And it's supposed to be permanent looking or permanent-ish. Permanent looking. With this Road Warrior VPN, it's a very temporary situation. The only time this VPN tunnel gets created is when this guy turns on his laptop, fires up the VPN software, and logs in either interactively with a username and password or with a saved set of credentials, which is kind of what you're doing. So your IP traffic gets encrypted, gets sent over this VPN tunnel through the internet, gets decrypted on this other side, thrown out onto this local network. Maybe it's a web server, or maybe you're actually going off back onto the internet. So for those of you that did get the VPN working to the EI lab, the way it was working was you open up your web browser and you try to go to ipmonkey.com. That request went all the way to this VPN gateway, which is running the VPN software that you logged into. And then it's going not onto your office network, it's going back out onto the internet, back off to wherever IP Monkey is, or IP Chicken, or whatever else you're looking for. And then that response comes back, hits this VPN gateway, and that gateway says, oh, that request was made by this guy through this VPN tunnel. Let me send it back to him. So It's multiple hops. You're sending data from here to here, out to the internet, then back to here, then back to you. It's a little slower, but it guarantees that everything is routed through corporate. Everything is routed through the corporate office router and gateway, and you have all of the advantages and control. If this router here and gateway, if either one of these two had special filters, special firewall rules to either allow or prevent certain traffic from going in and out, it's much safer than if you were just surfing the raw internet from right here. You're on your laptop, you're connected to the internet somehow, and then you're trying to go to whatever website you want to go to. First of all, there are certain websites you will not be able to go to depending on what country you're in. So let's say you're sitting in an airport in Beijing or Saudi Arabia, or some of these countries where the internet service providers are required by the federal law of that country to block certain websites because some countries don't have the freedoms that we have, or they're more socialistic or more communistic in terms of what they allow their citizens to see. Pornographic websites are blocked, for example. Websites that have been determined as subversive, having subversive data or subversive information on them, you can't get to from certain countries. Or it might not be that sort of a situation. It might just be that you're trying to access commercially protected information. For example, Netflix in this country, you can go to Netflix and you can watch certain videos that are available on Netflix by paying, what's Netflix now, 10 bucks a month? But Netflix has licensing requirements for different countries. Movies that come out and intellectual property that comes out is licensed in a particular country. So Netflix in the United States, you might be able to watch the latest Transformers movie here, but you can't watch it in Europe, or vice versa. Maybe you can watch some of the latest versions of films or episodics that are made in the UK or made in Europe that are not yet made available here. And the way that is controlled is by IP address. So for example, I used to like to watch, or I still do kind of watch, Doctor Who. Anybody ever heard of Doctor Who? It's been around for many, many years. It's an awesome science fiction series that's been around for almost as long as I've been alive. It's about a time traveling scientist who's 1,000 years old. Some people really get into it. Some people think it's hokey as crap, but I think it's interesting and fun. The newest seasons of Doctor Who come out in the UK first. So we're one season behind. We try to watch it on, even if we try to watch it on, BBC America, it's one season behind or several months behind. But if you are on a network provider in the UK, you can go to bbc.uk, bbc.co.uk, and I'm sorry, I typed that wrong. bbc.co.uk, and watch TV over the internet. Watch broadcast TV. We can't watch broadcast TV over the internet here for free. You have to pay for it. You either have to have a Netflix or a Sling account or DirecTV or Dish or Xfinity. You have to have some sort of account. It's not free. It's commercial television. It's protected. Now, there are people that try to get around that, like Lowcast, lowcast.org. Anybody ever heard of Lowcast? It says it's free. It's not really free. They ask for $5 a month donation. They let you watch for like an hour for free. And it's only in certain cities in the United States. So my point is that some people use the VPN to essentially get around or hide where they are because they can't access certain content based on the IP address from the country that they're sitting in. Or if you wanted to protect yourself, if you were afraid that your IP address, your public IP address, you go to ipmonkey.com. If you're afraid your public IP address is a target, you can download a lot of these security VPNs that McAfee puts out, or there's what's called NordVPN, that will essentially obscure what your public IP address is. It's kind of like allowing you to make a cell phone call from your cell phone, but it's putting out a different phone number, telephone number spoofing. So a lot of these Road Warrior VPNs are sold as a subscription to hide who you are. Unfortunately, a lot of hackers use it so that it makes them look like they are in another country or another area, or makes it look like they're actually within the company that they're trying to hack. So it's a powerful tool, just like a chainsaw is a very powerful tool, and you chop trees down. You can also chop people up with it too. It's a matter of how you use that tool. So keep these terms in mind. What's happening with your data is you're taking a higher layer data. This is layer 3 IP. It's an IP packet. Excuse me, I'm sorry. We're taking a layer 2 packet. Excuse me, layer 2 frame. Application data goes all the way down into a frame, throws it on our local LAN. That frame, if we're on a VPN, is encapsulated into an IP packet. So layer 2 goes back up to layer 3 because we can't transmit layer 2 across the internet. We can only transmit layer 3 with IP address. It gets sent through the internet, decapsulated or detunneled, if you will, back on the other side. That's why we call that a tunnel. So the term tunnel means taking a lower level protocol, encrypting it somehow into a higher level protocol, driving it. So it's kind of like this analogy. And this is true for certain tunnels in the world. Has anybody ever been in a tunnel where you cannot drive your car through the tunnel, but you could put your car on a train or a truck, and the truck would carry multiple cars and drive that entire chain of cars through the tunnel? Kind of like the original idea for the Channel Tunnel from the UK to France was like that, where individual cars were not allowed to drive on it, but the cars could essentially get on basically like a truck ferry. And the truck ferry would drive through the channel. It was safer that way. It was more efficient, less congested that way. Kind of like what you're doing with the VPN. So the advantages to VPN, and the reason that most companies do it, is it's very inexpensive. You don't have to get a dedicated connection, but you have all the capabilities. Once you set that up, or once you set that up, this here, sorry, that one, site-to-site VPN, this works just like a wide area network connection. This network can see everything on this network, and it's logically protected because it's encapsulated in a tunnel which nobody else can get into. It's protected, so it's almost as good. Now, yes, you can crack the passwords, but in the case of a site-to-site VPN, the reason we set up those reciprocal connections like that is so that we can basically tell this gateway and this gateway, if you get any requests to log into you from any other IP other than this 192.138, whatever at U of H, ignore it. Don't even let them in the door. Only let this one IP, which is static and hard coded into this device, even try to log into it. So it's fairly secure from that. Don't even let them in the door before they even get a chance to try to give the password. They don't have the right credentials. This is a little bit less secure because, of course, we have to leave this open because we don't know where this laptop is in the world. He could be coming from any country in the world, and because we've set it up like this on purpose. So this kind of a situation can be abused if somebody gets a hold of this laptop and they are able to guess the passwords, or they not even that laptop, they just know what the right IP address is, or domain name. Sometimes it's just a domain name, and the right username and password, and the right version of VPN and the right encryption, they can get in on your network as well. So although it says in the book that it's secure, that's kind of a gray area. Is it secure? Yes and no. The ultimate best security is lower down in layers. Layer 1 is the best physical security is the best security. If you can't get into a network physically, that's the best security. Layer 2 is the next best security. Once you bring your traffic up into a potential for a layer 3, once you've put a door in the wall, if somebody in the outside world has the right keys, they can get in that door. So security may be an issue. Inexpensive and flexible. Also, you can set these things up literally instantaneously. As long as there's an internet connection in one city and an internet connection in another city, and as long as they're reliable, you can go to Amazon.com or go up to Office Depot and buy inexpensive gateways that are compatible with each other and throw them in place, program them. We usually call it a nailed up connection. We nail them up and you've got an instant WAN. You didn't have to sign a contract with AT&T or Comcast or whoever. It didn't cost thousands of dollars to install. It doesn't cost thousands of dollars to run. The only thing you're paying for is whatever the cost of the internet connection is here in this city and whatever the cost of the internet connection is here. Maybe a couple $100. Much, much cheaper. Cheaper, instantaneous, but here's the disadvantages. Because, other than the security, because you're running it on the internet, your throughput is going to be extremely variable because you're essentially using a non-dedicated freeway. It's just like using a freeway in Houston here. Everybody can use the freeway in Houston. Or let's take another analogy. Let's take the toll road system here in Houston. As long as you've got a toll tag, you can get on that toll network. So as long as you have that VPN toll tag, you can get on that Harris County Toll Road Authority VPN toll road. Sometimes it's great. Sometimes you can go 70, 80 miles an hour. Other times, has anybody been on the toll road before where it's bumper to bumper traffic? Like at rush hour? It's variable. And you don't have any control over the traffic. It's not like you can tell the guy in front of you, hey, you're a fellow employee, get out of my way. They're going to say, screw you, I'm not related to you. I don't have to listen to what you tell me. In other words, in a shared environment, we don't know how fast the networking is going to be. Also, and this is what I started to get at before, there's multiple incompatible implementations from different organizations in different ways to do VPN. There's a bunch of different settings that you have to get exactly right in terms of the encryption. Not all the vendor equipment services are compatible, even though they say they are. Even if Microsoft says they're compatible with Cisco, there's certain things that don't work 100%, or you have to hold your tongue just right when you're typing in things, and that's why some of us were having some issues. Usually, the best way to set up a VPN is to get one technician that knows what he's doing to set up both the home site and the employee's laptop, or the remote site's device as well. When they're side by side in the same lab talking to each other, you know you got to set up, okay, I'm making these two talk to each other with a 6-foot crossover cable. Then I'll take the remote site's device, the router, the VPN capable device, put it in the mail and mail it to the remote site. Tell them, get it out, plug it in, connect it to your internet service. That should work. Okay, so in best design practices for WANs, when you need very secure, very sure networking, you might want to go with T-carrier service or Subnet service. Highest speed of T-carrier, though, only 4,500 megabits. If Subnet is available, and that's the big deal, why Subnet is not always the obvious choice, because the slowest level of Subnet, it's actually 52 megabits. The slowest level of Subnet, you'll notice, is faster than the fastest level of T-carrier service. Why not go with Subnet? Many times it is almost the same price or cheaper, because it's not, fiber optic cabling is not available everywhere. Fiber optic networking is less susceptible to going down. whenever you can, try to use Subnet service if you need a dedicated service. Also, these relative costs are high because, and the reason that one says moderate is many times there's already copper cabling coming to your building, which used to be telephone wire, or it used to be used for something else. Let's just take that telephone wire and use it for the T-carrier service. In many cases, there is not already fiber optic wiring coming to your building, unless you're a building which has been built within the last 20 years. What they're doing now, when a new building, a new multi-tenant building is built, almost always in a major city like Houston, is one of the things that you supply to that building other than electricity and water is a fiber connection. Maybe it's dark fiber, maybe it's lit up fiber, but you almost always go with a prevailing utility in the area, Comcast, Phonoscope, Level 3, whoever has fiber anywhere near that building, sign a contract with them and get it installed. Maybe it's not offering service, maybe just the cable is physically there for tenants to use. Package switch service, you do this when you still need high reliability, but you need a lower cost than a guaranteed network. So this here is like renting your very own lane on a freeway, on a multi-lane freeway. Packet switch service is like using the toll road where there is a reduced number of cars on that road, and it looks to you like you're the only guy in the road, but there are other cars on that road. That was the whole intention of toll roads. Anybody get real pissed off when you get on a toll? You paid money to get on this toll road. You said, I'm going to go take toll road to get to the airport because there's a lot of traffic on 69. You pay your 75 cents or a buck to get on the toll road and you stop in bumper to bumper traffic. How do they fix that? Yeah, same with HOV, exactly. I don't know if HOV is a great plan or not. Why do they make HOV one lane? Yeah, so when there's a lot of traffic, you know how they fix it? They raise the tolls. I mean, whoever's willing to pay for it, $3.50, $4.50. Harris County, Fort Bend County has some of the highest tolls in the country because we will pay for it. Go to another part of the country like Florida or New York, almost everything's a toll there, but it's a lot cheaper. And then VPN service is more like just using the regular freeway. You're not paying tolls. You're just using a regular freeway, but you're driving a tank on the freeway. And it's mostly secure, but it is susceptible to other traffic on that freeway. And this data rate, that 50 megabits per second, actually be higher than that. It totally depends on what the internet connections are in both locations and then everything in between it. The reliability used to be low, but now that most internet connections are pretty good, not necessarily pretty good, but internet connection is ubiquitous. Do you guys know what that term means, ubiquitous? It means it's everywhere. In fact, there's a networking company called Ubiquity. They're a wireless networking company that make access points outdoor, external access points. They call themselves Ubiquity. We are everywhere. So internet connection is ubiquitous in a lot of the world. If you are at a site that has not a very good internet connection, or you're at your home and it's not very good and the internet goes out, you can go down the street to Starbucks or to Target or to McDonald's even. I mean, everybody's got Wi-Fi these days. Or you can whip out your cell phone and use it as a Wi-Fi hotspot. So the reliability has gotten better only because of the ubiquitousness or the ubiquity of the amount of possible roads that you can get on, the amount of possible entrance ramps onto the internet, if you will. Relative cost, of course, the only component cost here is the cost of the original setup, if it was hardware that you're using site to site. But the recurring cost is just the cost of the internet services here. And it's instantaneous. You can set up a VPN in minutes versus weeks or months for these kinds of services because you have to sign up, get it contract signed, get it built out. Sometimes the cable needs to be physically brought to your building can take months. So each one of these most companies use some combination of all of these for their WAN connections. So if your network needs, if there's low to moderate traffic needs VPN, if the reliability is not that important. So if you're a salesperson out on the road somewhere, you're one guy. The reliability doesn't need to be super high there, because if you can't get on that network, it's only one employee being affected as opposed to 10 or 100 or 1,000 employees. If it's a high traffic need, you need to connect two locations together, you might need to use T3 or SONET service, or very high traffic, you might need to go with SONET service if it's available. Very stable and very predictable. Again, very, very expensive though. What can we do to improve WAN performance? Same thing that we do to improve backbone and LAN performance. We can either improve the devices. In improving the devices may not necessarily be changing out the devices, but change to a different WAN protocol. ATM, for example, and this is why you don't see DSL. Anybody ever heard of DSL? It's still available. AT&T has DSL. You can go Google for DSL. It's not very fast. It's maximum speed that you can get probably on DSL. It's asymmetric, first of all. It's about 20 megs down, 20 megabits per second down, and about 1 megabit per second up. It's much more asymmetrical than cable service. Cable service can be tuned a little bit so that you can get 50 down and 10 up, or 20 up if you pay more for it. But the ATM frames are very, very small, 53 byte frames. It's like putting all your people into a two-seater smart cars to get them from point A to point Z, as opposed to getting a big bus to put them all in. The cost of WAN hardware and services is decreasing. It used to be very expensive to get a T1. I remember getting our first T1 from our company to Blue Shield of Texas, because we were a Medicare processor, and it was required by the insurance company, required by Medicare. If you're going to transmit claims, either have to do it over a telephone, dial-up telephone line, which would be really slow, or a dedicated leased line connection. You couldn't do it over the internet, even though the internet existed already. They didn't consider it secure. So we had to pay $2,600 a month. And this is in $1985. So that was like $1985, that's like $8,000 a month today. Just to transmit claims to Medicare. And we weren't the big company. It's expensive. But these days you can get a T1, you get like just a T1 to the internet for about $500, a T1 from Houston to Dallas if you want to connect two offices together for about $800. You can get Metro Ethernet from Comcast or Time Warner or Phonoscope in different areas of the city for between $800 to $1,200, up to 10 megabit, 20 megabit, 30, 40, 50 megabit. Once you get over 50, it starts getting more expensive, but it's not much over 2,000 bucks. 2,000 bucks a month is about what you'll pay for a gigabit WAN connection from one major city in the United States to another major city in the United States. And then similar to LANs and backbone networks, WANs are experiencing standardization and commoditization, so that with standardized protocols that we use, and with the carriers deciding to interoperate with each other. For example, if you have a site in Houston and a site in Amarillo, Texas, and they don't have Comcast there, and I don't know if that's true or not, but let's say they don't. Let's say their Comcast has a hop point of presence in Houston, but they don't have one in Amarillo, but AT&T does. As long as they have a reciprocal agreement in place, and you pay both carriers, and they agree to pass traffic at layer 2, you can do that, but there has to be agreements in place between those different carriers. And so again, improving the devices, maybe just changing the protocols out, Improving the circuits, either get faster circuits or more of them, and then increasing the demand, or decreasing the demand, excuse me. So in this case here, if this is the host site up in the upper left-hand corner and this is the remote site in the lower right-hand corner, if there's a lot of data that sits on a server here in this office, that this office periodically needs to access, or maybe needs to access a lot, what you might want to do, and a lot of companies do this, is every night, assuming they're just a 9-to-5 style company, not a 24/7 company, they will take all the data on one server and download it, or upload it, I should say, to another server, like a copy of the server, make a copy of the database on this local network. So that when somebody on this local network requests data out of a database that normally is over here, it checks here on the local server to see if there's already a recent copy of it. And if last night's copy is good enough, it might be a lot of what marketing people and accounting people and people working in offices are looking at is historical transactional data, not current live data. We're looking at what happened last month. We're trying to generate reports. We're looking at data flows and sales numbers from the past 2 years. We don't care about what we're selling right now today. We care about what we sold last month or 2 months from now. So that kind of static historical data, once data is transactional, as it's become part of history, it's static. It doesn't change. It's not supposed to change. So a lot of companies keep multiple copies of their static transactional data in multiple cities. And then only maybe a little overnight process then reconciles any changes between those two databases. So only the changes go back and forth. There may be, with most databases, if it's a very large database, has a lot of transactions in it from several years, there might be only 1/10 of 1% of a change in that database. Maybe only 1,000 new records added a day, or 10,000 new records added per day. That's not very much at all to transmit over the internet. So that's reducing the demand by not sending those requests across the network, across the internet, when you can just get them off your local servers. Okay, so that's it for chapter 9. So let's talk about let's go through the instruction guide on taking exam 2. Let's look at these study notes, and then I'll go over the subnetting assignment, the first 2 or 3, and we'll do them together, okay? We will just do them together. So exam 2 study notes, I'll update that date just to make you guys more comfortable, but essentially it's the same thing. There's going to be only 30 multiple guess questions, not 40. There's going to be one multi-part essay question, and it's a big essay question, worth 25% of the test, and that is the subnetting part of the test. Now I ask a couple of extra questions, which should be just simple math, and I'll show you when we get to the subnetting part. When I start showing you the subnetting, I'll show you what those questions are. Questions are pulled from a pool in random question and answer order. Therefore, no 2 tests are going to be the same. You're going to take it online via Blackboard, same way as you did the first test. Had you guys taken Blackboard tests before my class before? Anybody ever is this your first experience? So Stacy, this was your first experience with Blackboard. What'd you think of it? Did it go okay for you? Or is that a yes? I think it still works okay. We have a couple of other tools that we can use, but Blackboard, not the best, but it seems to work good enough. I'm going to give you 3 hours, which is plenty of time. And in grading exam 1s, by the way, and again, I'm almost done. It's like 3 or 4 more I got to look at before I apply that curve. Some of you on the essay questions, when you were answering them, you gave me some really obscure, strange answers. You can use Google when you're taking the test, okay? You can use, just don't copy and paste. type it in your own words, but read the answer that you find in Google. If you're not sure and you can't find it in your notes or you didn't study that part, go Google it and see if you can try to answer it. And you guys understand why I allow you to do that during taking a test? The only thing I don't allow you to do, because it's not really fair, is to talk to each other. Talk to another human. Well, more specific than that, Ali, it's not just about learning to do it, because a lot of professors, you know, it's a closed book, closed note, you got to have it all in your head. Well, guess what? I don't know of any network manager in the world that has everything in their head. It would have to be a pretty big freaking head. I've forgotten more stuff than I know now, and I have to go look up stuff that I don't do every day, stuff that I used to be really good at 10 years ago. I can't remember how to do it. I used to be really good at making web pages, but I can't make web pages anymore. I don't remember how. So stuff that you don't touch every day, it's going to naturally leave your brain. Furthermore, you don't need to keep all of that minutia of technical data in your mind. So we've come to rely on Google. We've come to rely on being able to easily and quickly look things up. But here's a big issue, is a lot of people don't know how to properly Google for things. The biggest problem with the internet, because the internet's a great tool. But like most tools, guys, as you probably know, they can be used incorrectly, or the users of the tools haven't been properly educated in how to use them. The biggest problem with the internet as a tool is there's so much noise, so much wrong and false information, and I'm not talking about political stuff that the Russians are posting or that Antifa is posting or any of that. I'm talking about just people that are guessing on some things or information that gets changed about how certain types of traditional networking works or who invented what. Things change. History actually changes. History is not static. It gets rewritten all the time. So, or sometimes data just gets lost. Stuff that was known 20 years ago, nobody talks about it anymore, so it didn't get published and propagated on the internet. But there's just too much noise. Too much noise, sometimes very difficult to find what you're looking for. So that's what I'm trying to teach you guys, to use Google more, and how to formulate your queries is important. And I'll talk more about that in the next classes. So same rules, online tests, you can use anything you want. This is how I recommend that you take these tests. And I know I mentioned this in the last test, but take all of these bullet points. I know there's a lot from chapter 7. Not nearly as much from chapter 8, because chapter 8 wasn't a big chapter, and here's some from chapter 9. Take each one of these bullet points, open a new Word document or a Notepad document, whatever you want to open. LibreOffice document, whatever you use to write text with. Copy and paste each one of these bullet points. So I'll just copy this first one. Then go look in the PowerPoint. Look in the notes. There's notes for each chapter, chapter 6. Scroll back through the video for this chapter. Maybe it's a couple of different videos because, you know, it chopped a couple of chapters in half. Find the answer or answers that you're comfortable with, and then don't just paste them in here. Manually type them back out. Building block is cyclical. You know, it's got a design, technology design, needs analysis, technology design, cost analysis, write down a few details of it. So you're comfortable and confident with that answer, and then go to the next bullet point. What are the steps in the building block approach? What are the goals of the needs analysis? Answer each one of these questions by literally typing out whatever it is you found, even if it's verbatim, even if it's word for word. Because as I said before, there's something that happens in your brain when things go into your eyeballs or in your ears and out through your fingers onto a keyboard or out of your mouth, you remember it better. This is why you see a lot of people talking to themselves. If you see somebody talking, I talk to myself all the time. The reason I talk to myself is I'm trying to remember something better. So I say it over a couple times, so I hear it, it goes back into my brain, and I say it again. It's a proven fact. You're creating stronger neural memories of that. And then even if you can't remember it, you've got a nice self-made document that you've created in your words, in your handwriting, or your grammar, that you can then refer to rather than this thing and rather than Google when you're taking the test. So look up each one of these bullet points. There's going to be obviously more than 35 because, again, it's being pulled from a random set of questions. There's about 60 questions or even more because I add more every day. Not every day, but every semester. Now the essay question. It's going to look like the Subnet mask. And I just want to show you, because I probably didn't show you these, there's various places where you can find these links in the, oh, I guess it's broken now. If you Google for subnet mask, let's just Google for something, subnet mask tutorial, or actually subnet mask calculator. There are several, some of them are better than others on the internet, which will help you, and that you can use this for the subnetting assignment and for the test. It'll help you double check your work. That's actually not one of the better ones. Let's see if I can find a better one. Was that one? Sorry. Yeah, when Google moves things around, that's not a great one either. Where's the one that I like? I'm trying to find it. Okay, yeah, this is a good one. This is the one that I like. If I want an example of what a Class C network is, I can choose Class C. I heard Jake talk about what's a Class C. Oh, okay, Class C, here's an example of one. What's an example of a Class B? Let me click on that. Oh, here's a Class B network, 255.255.0.0. How many hosts per subnet? 65534, because that's 2 to the 16th power minus 2. But remember what I said, it's always minus 3, because you got to have one router on each network. Here are the appropriate allowed ranges to use for that. And here's Class A, 10.0.0, or you could type in your own stuff if you wanted to, at 12.0.0.0. And you can change the subnet mask to whatever you want. Let's just grab some random subnet mask value here, that. And that'll tell you if that was the starting number, and it'll tell you if you try to put in an invalid starting number. I'm just going to put that in, see what it tells me. It doesn't, it tells you that that address is within that range. That's not the beginning of the range. This is just a random IP address. That defines your range. If I type in 192.168.0.125, but I decide I want to change that subnet mask from the 255.255.255.0, which you usually see right there, to the next one down here, or maybe two of them down to 192, look how it changes the range. The range is now 65 to 126. I change that to 126, it'll probably complain to me, say can't do that. No, 127. I'll have to hit enter, excuse me. So see how it changes things? You can change any of these items. You can say, well, I want to do the CRDR notation, the /24, change it to that, and it modifies the subnet mask. So this calculator right here at this subnet-calculator.com is a useful little tool to help you. It doesn't necessarily teach you the concepts of what we're trying to do in the subnet assignment, but it'll help you check it. Okay, so let's take a look at, if you guys have a little bit of time, here's 3:12, so I'll just go as long as I've got some time for here. I need to stop a little bit before 4 so that I can get ready for my next class. Let's go ahead and try this version. Okay. I will begin. So internet provider has a class B address. So all of that from 00 all the way to 255, 255. To break up, you'll need to rank each one of these companies based on the projected growth needs. Keep this in mind on the test. The projected growth needs might be different for each company. These growth needs are given to you by the customer. One customer will come to you and say, we don't plan to grow at all. Another customer will come to you and say, we plan to grow 50% in the next 3 years. Use those values on each one of the questions. So let's begin. This is what the online version looks like for those of you that haven't seen it yet. It scrolls off the screen there. So basically what I've drawn for you here is a bunch of blocks here. Each one of these blocks has 16 spaces in it. Each one of these lines has a maximum of 255, from 0 to 255, or 256 spaces. And then I've drawn just the first one to about the first 12 lines here. I haven't drawn the entire Class B subnet because we don't need all of that space, okay? So here are the different entities here, and this is the corresponding letter or corresponding answer that you're going to use in each one of these blocks. So here's the first question. My Facebook needs 480 addresses, not including a router, with a 25% growth. Now, each one of these has a little box on work notes, and if you do it, it will count off if you don't put something in there. If the answer is really obvious, just put, duh, or just put something in there so that it won't count off. It's looking for some character. So company ranking, we don't know yet. We don't know if that's going to be number 1 or not. We need to do that calculation first. What's the projected IP address needs, not including a gateway? That's going to be whatever the given is times their growth, times 1.25 equals, what's 480 times 1.25? If you're lazy, like we all are these days, use a calculator. 480 times 1.25. Don't make a mistake on this, okay? Thank you, Nicole. Did you know it on the top of your head, Saray and Stacy, or did you look it up? I go ahead and use a calculator anyway, just to double check. So the answer was 600. So that's your projected needs. Don't add 3 to that. Don't do anything special to that. Skip down to question 3. Do the projected needs for all of them. What's 50 times 1.25? That's kind of a tricky one. What's 50 times 1.25 to get the projected needs? Somebody calc it out real quick. Why do we have to do 1.25? That's simple 63. Math. If I'm trying to increase something by 25% in math, you take 1.25, because 25% is 0.25. So the answer, right, the answer would have been 62.5, but you will get counted off. You always have to round up. There's no such thing as 0.25 of a computer or 0.5 of a host. So always round up. So 63 is that answer. So go through and do all of those, and you'll be able to do this on the test as well. Only 5 addresses with a 25% growth, so that's 5 times 1.25.
And quick question, sir. Maybe it's a
equals. Yeah.
Is there a reason why you're not adding the 3?
Yeah, because in terms of this, I'm asking you right there. Just tell me what the company's projected needs are. I'm not trying to calculate a network size. I'm just calculating projected needs. That's not really part of networking, and that throws some people off. But the reason I'm asking you to do that is so that you get in the habit of asking that question of a department or an organization. How much do you think you're going to grow in the next year or next 3 years, or what do you think your projected needs might be? And the most common answer you're going to get is in the form of a percentage. We're going to grow, I don't know, arbitrarily 10%, 20%, 30%, maybe they don't know. 5 times 1.25 equals 6.25 or 7. You got to round that up. Don't make mistakes on those because those will throw you off. And then after you answer all of those, I'm not going to answer all of them right now, but I'm going to go back and figure out which one has the greatest projected needs. It happens to be these guys. Okay? So let's rank them. They're number 1. Go to the next guys, which I think the next guys are going to be, if I scroll through here, I think it's 2 to the 8th power company. Yeah, there we go. They need 256 addresses times 1.25 equals, what is that, 323? 320, excuse me. 320, not 323, but 320. Okay, so they're going to end up being number 2. We'll do them next. Okay, and the test is presented to you like this, all in one page, big long page. You can scroll up and down. I don't present the questions one at a time. That way you can do all this at once. All right, in this next part here, binary net mask, I'm looking for how many 1s. There's 4 boxes here. And depending on how your computer is displaying this, keep in mind that your screen might word wrap some of that. It might do that. 1, 2, 3, and 4. Probably not on most people's modern computers, but I have had people get confused by that. Okay, so how do we calculate the binary net mask? Come over here to the work notes. Oh, I'm sorry, I'm on the wrong guy here. Work notes. Math. I'm just gonna put math there. That's how I know he's number 1. Math. Binary net mask. What power of 2? This is how you do it. 2 to the what power is greater than or equal to the needs, which are 600. I'm going to put that in parentheses, 600 plus 3. That's where you add the 3. So what power of 2 is greater than or equal to 603? The answer is 2 to the what? What's 2 to the 8th power? 2 to the 8th power is only 256. That's not enough. 2 to the 9th power is 512. It's getting close. Still not big enough. It's 2 to the 10th power. So the answer in your notes here is 2 to the 10th power. So that's what I'm looking for over there. The binary net mask is very easy now. This tells me how many zeros I'm going to have. This is IP version 4, which is 32 bits. If you want to start from the right and go back to the left, that's fine. So each one of these octets is 8 bits. I know I said 4. I need 10 of those to be zeros. So let's fill up the first 8, or the last 8, I should say. So 1, 2, 3, 4, 5, 6, 7, 8. Make sure you closely count those. If you stick a 9th zero in, it'll count off. I'll try to go back and technically fix those, but then I need 2 more zeros, 0, 0. Then I need to fill all the rest of it with 1. So 1, 2, 3, 4, 5, 6. So now there's 8 bits there. 1, 2, 3, 4, 5, 6, 7, 8 bits there. 1, 2, 3, 4, 5, 6, 7, 8 bits there. Okay. What if you put 2 to the 10th notes? That's considered incorrect. No, it's not considered incorrect. I'm not grading based on the notes array. The only thing that the grader actually does is it looks to see that you type something in that field. Okay, because a lot of people, you can do this in your head, some of it, but I want to see your notes so that if you do make a boneheaded mistake, or maybe not a boneheaded, it's just a simple mistake. You miscalculated that. You did times 0.35 instead of 1.5, I will be able to give you partial credit if I see something in the notes. For the final exam, I don't recall if I count that box or not, but just put something in. Even if it's real obvious, just type in, the letter A or something, or a 0. It's pretty much looking for anything in there. Decimal net mask, we can go and we can be lazy and convert that into decimal by using a net mask conversion table. Try to find a good one here on the internet. There's a pretty good one there. So here's the line I'm looking for. There's the 22 ones and the 10 zeros. It says there's your net mask right there. 255, 255, 2520. It also tells you /22, which is a CIDR notation, so you can go ahead and remember that now too. So go back over to the assignment. 255.255.252, excuse me, .0, not 8 zeros, just 1 0. You can go ahead and put in that whatever goes after that slash. It's going to be a /22. And then since you know these are the biggest guys, we can go ahead now, once we get to this section, we need to start looking in the chart. 129.7.something. Where do we put these guys? Let's put them in the first few spaces here. How many spaces are they going to take up? They're going to take up 2 to the 10th spaces. So what is, let's see, use a chart, type that in. What is 2 to the 10th power? And why do I have to do 2 to the 10th power? Because that's what I had to allocate. 2 to the 10th power is 1,024. That's right. In this chart, how many lines is 1,024 if each one of these lines is 256 spaces? 4 of them, that's right. So I need to stick an M, and I don't think it's case sensitive, but you can turn on your caps lock.
Excuse me, can you repeat how do you know if you can you allocate 4 lines?
Because I need, do you understand how I came up with the 1,024 number?
Yes, 2 to the 10th power.
So 1,024, if each one of these lines is 256 spaces, from 0 to 255, what is 1,024 divided by 4? It's 255. So there's 255, there's 512, there's 768, there's 1,024. Yeah, so who was talking just now? Because Arsalan's got it. Each line is 256, each block is 16. It's just simple geography here. So think about this as a boat ferry, and there are no lanes longer than 256 spaces. And the first vehicle that I'm putting in this boat happens to take up the entire length of the ferry, and it's 4 lanes wide. It's a big thing. Now I'm going to end up wasting some space within this block, but that's how you have to allocate it. So I've finished allocating that entire block. The next company that's going to go in is going to start right there, whatever it is. Let's go finish answering this. So that's 129.7.0.0, not .1, because it's this upper left corner right there. That's the network number. Whatever that upper left corner is, there's a 0 there and there's a 0 there. This is just a simple chart. Broadcast address is the lower right corner. So go to the lower right corner of everything that I filled in. And this 4th line, by the way, started with 129.7.3 dot 255. That's literally that spot right there in the lower right corner. So your network number and your broadcast address are defining the size of your rectangle, the upper left and the lower right corner. That you didn't know you'd be doing geometry in networking. A lot of people mess that up. So make sure that you understand that concept. 3.255. It's not 0.255. So if I said 0.255, I'm only talking about this top line, right to there. Okay? Hopefully that's pretty easy to understand. Router address. Where should I stick my router? Let's stick the bus driver in the first seat on the bus. So it's going to be the very next number right after this one. So 129.7.0.1. The very next number after my network address. Broadcast address. Looked at chart. Router address. Put in the first space. Can't put them at 0.0. It's got to be at 0.1. Can't sit on the outside of the bus. Range of addresses is going to be all the remaining addresses in that range, 129.7.0.2 all the way through 129.7.3, because there's a 3 there, .254. So these numbers, you got to be careful, by the way, because if you mess this stuff up here, all the other answers are going to be wrong. Because these two are very easy to figure out. It's the router address is just the very next number after the network address. The broadcast address is the very next, or the previous number just before the broadcast address. 254. Maximum number of hosts in this block. That's easy to figure out. We'll take the, again, let's see. Broad range of addresses. Look at chart. Remaining spaces. Seats or spaces, whatever you want to call it there. Maximum number of hosts, that's easy to figure out. I take the 1,024 from this answer, and I subtract 3. The 3 is the network address takes up 1, broadcast address takes up 1, router takes up 1. 1,024 minus 1, 2, 3. So the answer in this case is 1,021. Now, how many addresses are wasted? Pretty easy to figure that one out. How many addresses are wasted? Well, that happens to be 1,021 that I just figured out minus the original projected needs, 600. What's 1,021 minus 600? What's the answer, Sreya? Should be what, 421, right? What does that imply? What does that mean, wasted addresses? That means there's 421 empty buses on that, empty seats on that bus with 1,021 seats on it.
So for those, I'm sorry, for those last two, it says not including the gateway router. So I did 1,024 minus 2 and didn't include the gateway router in that number.
But that's why I'm saying that. I see what you're saying. I'm trying to tell people, go back and fix it if you already submitted it, Nicole. But
okay.
What I'm trying to get the point across is that when I, as a network manager, am calculating maximum number of hosts, it makes sense to me to take out that gateway in calculating the maximum number of hosts, because your gateway, although it is a host on your network, it's not your host. You can't do anything with it. It's a requirement.
Okay, so for this one, it would be minus
So it's
3.
always minus 3.
Okay, perfect.
So the formula for this line in calculating is the answer here in the work notes minus the original projected needs, which will get you to 421. Oh, I'm sorry. That answer, that's what we're talking about. To get that, you take the 2 to the whatever the power, 1,024, and you subtract 3, because I want you to take out that number, and the router. Now, as I was saying, in many of these calculators that you use, those online net mass calculators, I don't know where it was, let's see. They will somewhat disagree, or they will somewhat mislead you. There's one. They will say host per subnet, like in this case, it's here. Let me change the subnet mask to match it. So there's a subnet mask. They'll say 1,022. So it is a little bit misleading. Yes, there are potentially 1,022 hosts on that LAN, because the network number can't be used for a host, broadcast address can't be used for a host, but that very first host, the router, is a special purpose device. Just like the seat on a bus, for the bus driver, it's a seat, and somebody could sit in that seat, but it's reserved for the bus driver, and he has one task: to drive that bus. He's not a participant in your little field trip wherever the bus is going. He has to stay with the bus, because that's his job. He guards the bus. You guys go on into the museum, kids, and have fun or whatever. If you remember that, back to your little bus trips to the museum. Did you guys take field trips, or am I just assuming that's a global thing? Or you took different cars to get places?
Yes.
Or you took a limo somewhere. Say you take a limo to a club, the limo driver doesn't get to come into the club much as he wants to. You make him wait out with the limo, or he goes off and does something else. All right, so that was the answer to that one. Let's keep going. The next one is going to be 2 to the 8th power. I happen to know that. So let's do this one. 256 times 125 equals the 320, so that's why I put the 320 there. Binary net mask, I asked myself this question: what power of 2 is greater than or equal to, in parentheses, 320 plus 3, so I add the 3 there. What power of 2 is greater than or equal to 323? Well, again, you could go look at one of those binary calculators or use your own calculator and just say, you know, what's 2 to the 8th power? 2 to the, and you can just hit this a bunch of times. 4, 16, that's 2 to the 4th power, 5th power, oh, excuse me. I doubled it every time. I don't think the simple calculator can do 2 to the 8th power. Let's see if I can do scientific. There we go, x to the y. 2 to the 8th power. Wait a minute. 2 to the 8th power. There we go. 256. That's not big enough. I need 320. 2 to the 9th power. 512. Oh, good. That's big enough. Let's stick that in. Let's throw my calculator over here. 512. In other words, 2 to the 9th power equals 512. We don't care about the 512. What we care about here is the power. That tells me how many zeros. So here's 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Did I count it? 1, 2, 3, 4, 5, 6, 7, 8. And here's the ninth one. And then 7 more ones. 1, 2, 3, 4, 5, 6, 7 to fill out that octet. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. To get that into decimal, I'm just going to go refer again to that chart that I had found earlier. Where was it? And there it is right here. 255, 255, 254.0. It's a /23. 255.255.254.0 /23. Now I got to look up in the chart. Where can I start this guy? The chart. Look at unused table. He's obviously going to start with 129.7.4 something because I've already used 3, so I'm just going to be 4 something. Let's go look up in the chart here. 4.0. It's going to start right there. We're supposed to use the number 2 to indicate 2 to the 8th power, so we know he's at least that big. How big is he? He's 512. How do we know he's 512? Because that's what we calculated right there, 512. So we have to indicate in the chart there 512 spaces. Each one of those blocks is 16 spaces, so 2, 2, 2, 2, 2, 2, 2. So there's 256 right there. Here comes another 256. 2, 2, 2, 2, 2, 2. And we're done. You agree that what I just highlighted, what I just indicated was 512? Hopefully you did. So my network number is that spot right there in the upper left-hand corner, or in other words, that number, 129.7.4.0. And while I'm sitting here, I'll go ahead and look for the broadcast address, which is a lower right-hand corner way over here, which is going to be on this next line, 129.7.5 all the way to the end, 255. So let me just keep that in my head. That's easy to remember. 4.0 to 5.255. 4.0 to 5.255. Excuse me. Router address, easy. The next number past the network address. Range of addresses, next number past the router address, 2. That's the kid that always sits behind the bus driver. 129.7.5.254. That's the kid that sits in the back of the bus and smokes marijuana. Which was a thing back in the 70s. Maybe it's not a thing anymore. Or the kid that causes trouble, a kid that sleeps in the back. I used to fall asleep on the bus, and I sat behind the bus driver when I fell asleep, so the bus driver could turn around and whack me in the head and say, "You're home, get off the bus." Maximum number of hosts in this block. And again, all these answers are chart. I just looked at the chart to figure this out. Maximum number of hosts in the block, that's going to be the calculation up here, the 512 minus 3. 512 minus 3. So 509. Number of unused addresses, it's the 509 minus the original needs, which was 320. What's my 509 minus 320? Can I repeat how I'm getting the ranges, Ali? All I'm doing is I'm looking, do you understand how I'm getting the network numbers? Just the very first number in the range. Getting the network number by simply looking at the chart. I'm getting the broadcast address by adding 512 to that network number. 129.7.4. Half of 512, 256, puts me down at the end of that chart. Got to scroll back to the next line, use up the whole next line. So it's 4.0 upper left-hand corner all the way down to 5.255 in the lower right corner. Do you understand that? Okay, if you understand that, the range is just basically all of the seats. I'm just counting if all the seats are sequentially numbered on a bus. I'm just numbering the seats on the bus. The first seat on this bus is 129.7.4.1, where the bus driver, aka the router, sits, and then all the other seats from here all the way down to the end of this row, and then all the way down to the end of this row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, blah, 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 all the way till I hit 255. Then I have to stop there and go start counting 129.7.5.1. By the way, 129.7.5.1 is a valid host address. It just happens to be, it starts with a 1, so it looks a little weird, but the number before it is odd. So that is a clue for you. That helps you understand that that's a valid IP address I can give to a host. So 1, 2, 3, 4, 5, 6, 7, 8, blah, 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 all the way to 255. Okay, so thank you, Franklin, for that math. So the answer was, the simple math was 189. So you wasted, there's 189, whoops, what did I do there? There's 189 available seats on that network. Okay, let's take a look at some trends here, or some things that will help you know whether you've done this right or not. Almost always, not always, but almost always, your network number, almost always going to be an even number. The network address is the same thing as network number, by the way. Almost always going to be an even number. That's either going to be a 0 or a 32 or a 64 or 128. It's usually it's going to be some power of 2. Not only is it going to be an even number, it has to be some power of 2. It will never be 6. It'll never be 12. It'll never be 18. Although those are even numbers, those are not an even power of 2. It can be 4. It can be 8. It can be 16, 32, 64, 128, not 256. It can be 128 plus 4. It could be 132. As long as it's some combination of 2 to the something power. It can be 192 because that's 2 to the 7th power plus 2 to the 6th power. That's okay to do. Okay, the broadcast address is almost always going to be an odd number. You will almost never, I can't think of any cases where you will see an even broadcast address. So when you're filling these things out, you start typing in 256 there, go, wait a minute, that's an even number. I probably need to go back one. If I'm putting in 128 there, wait a minute, oh, I must have miscounted. I probably mean 127, not 128. Some people make the mistake of counting into the next range, especially when you start answering some of these questions and you get into the very small ranges, which only take up 32 seats or 16 seats or even 8 seats. You'll start counting into the next range. Broadcast address, always an odd number. Router address, again, almost always an odd number because it's following whatever the network address is, which is almost always even. Range of addresses is always going to be some range that's right after the router address and right before the broadcast address. So 4.2 because that comes right after 4.1, and 5.254 because that comes right before 5.255. The bookends. Can I go over an example with smaller needs? Yes, I will. To get there, I've got to do one more that's maybe a couple more. Let's do, I tell you what we'll do. I'm going to pretend that a few of these are not here. Now, this is not going to be the right answers for these questions based on where I'm going to put them in the chart, but I'm going to do this for purposes of knowing what to do when they're really, let's take TinyCo because they're so tiny. TinyCo. They only need 3 addresses because they are a tiny company. Let's pretend we have question 1, 10, and 8 now is it. So TinyCo, we'll rank them as the 3rd. Only have 3 companies in my example short world here. And I used math to figure that out. Projected needs, what is 3 times 1.25 equals what? 4, right? 3 times 1.25 is 4. That's an easy one, I think. I have to use my calculator because I don't trust myself. 3 times 1.25. 3 times 1.225 equals, yeah, we have to round it up, 4. So 4, projected needs is 4. Binary net match, 2 to the what power is greater than or equal to 3 plus 4, or 4 plus 3. It's always something plus 3. So that's only 7. 2 to the what power is greater than or equal to 7. That would be 2 to the 3rd power. Happens to equal what? Equals 8, right? 2 to the 3rd power is 8. So there's my number of zeros. Only 3 zeros. This is a very small section. So this is going to be all ones. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Decimal net mask. I'll go look in the chart, and that's going to convert into 255, 255, 255. Let's look in the chart. Where's my chart? 248, and it's a /29. 248. It's a /29. Then I'll look up in my chart, and let's just pretend for grins and giggles. Let's pretend that, because I don't want to start it down here. I want to confuse you guys a little bit. I'm going to pretend that these next 4 blocks were taken by somebody else. Let's just say those were taken. And by the way, when you're taking up these blocks, they also have to be taken up in some power of 2. You have to take up 1 block, 2 block, 4 blocks, 8 blocks, not 5, but 8. So you will never start anybody if if somebody's taking up 3 blocks and you try to start them in block 4, you have to wonder to yourself, well, wait a minute, that's an uneven block there. It's not a power of 2. So let's pretend that, again, this isn't right. Don't take this verbatim as the answer for this assignment because I've removed some of the entities. Let's assume we need to stick them there. What do I see in the chart? 129.7.6 dot, not 0, dot 64. 129.7.6.64. So let's go figure that out, or let's go write that down. Now this one is a little bit tricky, and I will take 2 answers on this one. What's the broadcast address? Now some people will get a little bit lazy and they'll look in the chart, or they will get complacent and they'll look in the chart. I'm gonna go, okay, well each one of these blocks is 16 spaces, right? 13 of which are actually usable. With each one of those blocks is 16 spaces. So that spot right there, 16 is greater than the 7 that I need, or greater than the 2 to the 3rd power, which is 8. So my broadcast address could be 129.7.6.63, the last one there, but that's actually incorrect given that subnet mask, because it's only 2 to the 8th power. Oh, excuse me, only 2 to the 3rd power, or 8. It really ends up being the middle of this block. Okay, now you can't really show that like X, but not the second half. Now the only reason I did that is because if I had tried to break up this chart into a whole bunch, 32 blocks of 8, it would have scrolled way the hell out here off the screen. It would have gone on for 4 screens that way. Okay.
Would you take /28 then as well?
Well, here's what I would do. Here's what it would be correct. If you said, well, I want to take up that whole thing, that's right. You're exactly right. I would change it to say, well, I guess Jake wants me to only allocate a minimum block of 16. So I would modify my answer. Let me show you both ways. That's a good question. Thanks for pointing that out. I would modify that. Say, well, my minimum block is 16 just because that's what we sell. Okay. That would have to be a /28. And that would have to change to 4 zeros. You guys understand why? Because the zeros indicate 2 to the what power? 2 to the 4th power. 2 to 4 zeros is 16. If it's only 2 to the 3rd power, which is all I need for this company, and by the way, that would become 240 in that case. But if I change that back to what my true minimum needs are, that becomes 248. That becomes /29. The broadcast address is 129.7.6. And here's how to simply figure this out. Take 64, which is the network number, add 8 to it, because there's the 8. So what's 64 plus 8? 72, and then go back 1, because you got to get back into that space. So what's the answer for the broadcast address? 71. Do you understand that? Because you can't, this counts. When we start counting, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We actually start counting at 0 when we're doing this math. So 129.7.6.64, you just hold your fingers up. 64, 65, 66, 67, 68, 69, 70, 71. I've got 8 fingers up. So it's not 72, it's 71. It throws people off a little bit. Did it throw you off, Franklin? Did you think it was 72?
No, it threw me off that I thought we could only, that's initially what I had, but then I figured, okay, well, maybe we can only break it down by 16, and that's how you have it. So
and
that's
I understand that, and I did that on purpose.
Okay.
On the exam, there's a similar situation. And that's because I'm trying to also teach you not just to rely on the chart. not just to rely on actual physical geographic blocks here. This is an easier way, and the reason I use this blocking when I teach this, and I've been teaching this a long time, and I think I teach it better than a lot of other videos and people I've seen trying to teach this to conceptually show people, is they don't use a block chart like this. But when you get good enough, you realize, oh, I can just do this via math. I don't really need to use a block chart. Whatever my network address number is, my network number, if I'm at 64 and the size of my block is only 8, it's some power of 2, add the 8 to the 64, subtract 1 to get back to the last spot in the block. If it started at 128 and the block was 16, what's 128 plus 16? It's 130, 148. It's 144 minus 1. You get back to 143. So you can do it with math. You don't need the chart. The chart is just to help you conceptually understand it, because you can understand an upper right-hand corner and a lower left-hand corner. Lower left-hand corner when you're trying to figure out the area of a rectangle. These are just rectangles. Subnets have to be a rectangle. You will never have a subnet. And this is a popular mistake. And this is why I have people draw this out. Some people do this when they're calculating this stuff out. They'll go and then they'll stop after the 320. They'll say, okay, there's 256, there's 512, and then here's 16, blah, 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 and then they'll stop right there. And then they won't put anything in the rest of it. Okay, I'm done. I allocated out as many blocks as I needed. And then they'll go and they'll start doing the next company bumped right up next to. Here, 2 common mistakes that people make. Does that answer your question, Shreya, on how you do a smaller one? Some people make that mistake, go, okay, 2 to the 8th power, they're next. 2, 2, 2, 2, and they'll fill in 32 of these. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay, but you can't do that because that's not a rectangle. That's a weird Tetris-y looking thing, okay? The M is not a rectangle. It looks like it would be like a car with a chunk taken out of it. So that's another concept, another visual concept, which is a hint for you. All of your subnets have to be rectangles, and the rectangles have to be in sizes of some power of 2 width and some power of 2 height. It can be 1 block high, 2 blocks high, 4 blocks high, can't be 3, got to be 4 or 8 or 16 or 32, nothing in the middle. And it can either be 1 block or 2 block or 4 blocks or 8 blocks. And if I could draw this map smaller, if I had the ability to make more divisions here, I could have drawn 1 single block for all 256 potential spaces, but it would be way too hard to try to convert that into a spread. You can do it on a spreadsheet. Some people do this with a spreadsheet. They open a spreadsheet and draw 200 or create 256 columns and do it that way. If you'd rather do this on a spreadsheet first, that might be easier to conceptually help you. And then in the spreadsheet, you can, instead of using letters like this, you can change the background coloring and highlight that. Okay, so that is a common mistake to do that. It's also a common mistake to do this. Let's say I've allocated this half of this line to, the next company, 129.7.5. I've allocated half. 2, 3, 4, 5, 6, 7, 8. Next company comes along, I only need 1/4 of a line, or 2 to the 5th power, or 32. Or excuse me, 2 to the 6th power, which is 64. That would be 1, 2, 3, 4 blocks, but instead of putting them there, I'll put them down here. Why? And then the next company only needs 32 spaces or 16 blocks, and I'll put them here, ZZ. And then the next company only needs 1 block, so I'll put them here. I will count off if you do that. Now, is that technically correct and okay to do? Yes, it is. Technically correct and okay to do, but what have you done as a network manager? You have wasted space. In other words, if you did not allocate this space, and then another company, and you filled up this, or if you didn't allocate the rest of this line, and you put a little company of 32 on that line, and then another company of 255 comes along, you may not have any space left in your table to put it in there, or 256, I should say. So pack them together. In other words, stick these 4 Ys. Don't stick them there on the next line. And I tell you that in the instructions. Don't waste space. That's my point. Put the 4 Ys there. Y. Excuse me. Y. And then put the 2 Zs, or if the next guy needs 2 blocks. And then if the next guy needs just 1 block, put him there. And then you'll have that. So yes, you can still say, if you made a mistake, I will allow you to still redo it up until you take exam 2. Okay? Do it as many times as you like before exam 2. I will grade the most recent one. So Nicole, I think you said you made a mistake. Franklin, you made a mistake on the allocate, or you didn't really make a mistake. You made some assumptions based on the graphical blocks I gave you. Go ahead and resubmit it, fix it. I know you got to redo the math again, but it's just gonna, you're just gonna have better studying because of that. Okay, it's almost 4. Didn't realize it was 4 yet, so I need to go start my next class. If you guys have any questions about the subnetting assignment after today, which I don't think you should, I think this is helpful, or exam 1, wait for any more questions on exam 1 till after you take exam 2. I will most likely make exam 2 available tomorrow evening. Tomorrow evening will be Wednesday, maybe Thursday, but I'll give you basically through all of this weekend to take it. I'd rather that you not wait till all of this weekend to take it. Okay, don't worry about the draw.io right now. I'll take a look at it, but don't worry about it. I need to start my next class. I'm going to go ahead and stop sharing and stop the recording. I will see you guys tomorrow in class. We will start on chapter 10, and I will also talk about the Wireshark assignment, which I want everybody to do still. You'll just do it on your home computer if you're able to. Okay? See you guys tomorrow.